Got a lot of work to do, got a lot of things to clean up. Let's get started. Tailstock's out. Now we can see back in there a little better. By having the countershaft sit on a plate that's attached to that hinge and the hinge bolted to the table, I'll be able to use the hinge as a pivot point to adjust the tension on the belt. Having this By having the motor mounted to the plate along with the jack shaft, those two will be a unit. So whatever adjustment I put into the motor mount is going to stay when I tilt the jack shaft. Cardboard's actually fairly easy to lay out, especially if you have a nice big rafter square. And it's just a matter of setting up the drive onto the template. Motor towards the back, countershaft towards the front. Checking shaft alignment. I want to have the edges of the belt pulleys in line with each other. To check the pulley alignment before I mark out the template, I want to make sure that I have the counter shaft square with the end of the plate. I'm doing that by taking the end of the casting and setting that up in flush with the end of the cardboard. So this counter shaft is completely in the corner of the template. Now I'm checking to make sure that I've got it square with the edge of the template by sighting down the pulley, because the casting has a little bit of imperfection in it just because it's made in a mold, and they never really use that as an alignment tool. Now I put a square against both sides of the big pulley, and then I sweep down, and it should hit just like that. Now that doesn't happen very often, but it's nearly perfect. Touch both sides of the big pulley and sweep along and touch both sides of the little pulley. No daylight here, no daylight there. Now I have the motor shaft and the pulley aligned. And to finish making the template, to line up the motor mounts, Make a circle inside of the slot on the motor mount itself. And just so I can get it, see it with the camera easier, I move the motor with the countershaft still held in place. I mark out the holes for the countershaft mount. For the cost of a little bit of time and a piece of cardboard, I've been able to make a mock-up of the plate. That way I don't spend time, effort, and money getting a plate cut and then find out it's the wrong size. With the countershaft mounted in the front of the plate and the motor mounted in the back, the countershaft is going to be able to pivot and put tension on the belt. The motor mounted in the back will provide a weight, fairly considerable one, about 10-15 pounds, to keep tension on the flat belt. So that should make the tensioner a little bit of that should make the tensioner an easier plan. So now I have to go down to Alro Steel and buy a piece of plate steel and then lay out and drill holes to mount the countershaft to and to mount this hinge to the plate. I really seriously thought about welding it in place, but if you look, the two holes on the hinge line up exactly with the two holes on the countershaft. So I'm thinking I want to drill two holes through this, and this, bolt the countershaft to it, tie the whole thing together, put one bolt back there, and have it all done one nice neat package. That way if I change my mind as far as location, I can move it around. Later I might tack it together, but I don't think it'd be necessary, and this should be more than sturdy enough to handle the load of the motor and the tensioner. The other thing is, this hinge, it's a special one. It has nylon bushings in it. The nylon bushings will keep it from wearing. I won't get that annoying squeak like you do on a gate. This is designed to be a barn door hinge, and it's designed to be out in the elements. Now, travel on this thing is going to be minimal, but being able to avoid the squeak, squeak, squeak when it's turning, it's going to be a blessing. So I don't want to weld on this, and I don't want to heat that and damage my bearings. So I think bolting it together is a much better plan.